Akash has near 100% utilization for high density GPUs and about 50% utilization cumulative for all resources, all types of GPUs, including the low end GPUs. That is a significantly higher utilization than anything you heard of in crypto. So now we have a interesting problem where traditionally crypto has been good at oversupply and less demand. Here we have the opposite problem: high demand and less supply.
Hey everyone, Sam here. If you're like Dan and I, you probably don't pay a ton of attention to the institutional / macro side of things in crypto and are laser focused on the degen shenanigans happening on chain. However, in order to onboard the first $1 trillion of capital on chain, it's incredibly important to hear from these institutional players and get them involved. That's why we're excited about hosting the Digital Asset Summit in 2024 in London, the land of tasty pastries. Be sure to join us at the event next year, and we will tell you how to get 20% off your ticket a little bit later in the show. What's up, everyone? Welcome back to another episode of 0x Research. Before we dive into today's episode, a quick word from our sponsor, Hexens, the most hardcore security team in Web3, pioneering in zk and novel cryptography. Hexens is trusted by tier 1 protocols like Polygon, including the work on their new zkEVM, Mantle, RISC-0, Lido, 1inch, Nubank, and more. You'll hear a little bit more about them later in the show, but today is October 13th, and we are joined by Greg Osuri, one of the core contributors to Akash, a decentralized computing network built on a Cosmos app-specific chain. Greg, thanks for joining us.
Thank you so much, Sam. Super excited to be here.
Awesome. Well, let's just jump right into it. I think it'd be super helpful if you just kind of laid the environment of the cloud computing industry and how Akash kind of fits into that scene.
Sure. If you think about cloud arguably is a fabric that keeps a modern society together. Right? It is such an incredibly important and invisible layer in our collective prosperity. Without cloud, even basic functions that you perform in a modern societies are impossible. So cloud is very important. All of us pay a cloud tax, you and me. We just don't realize it. For context, 50% of all the subscription fees you pay for online services goes to one of the cloud providers. You just don't know it. Cloud brings incredible value in enabling these amazing services for us and storing our data. And now the question is how much of a control you have on this invisible layer that's so important to us. The answer is very, very little. So what does that translate to? That translates to uncontrollable costs, selective innovation, sometimes extremely anti-competitive practices, and then essentially an oligopoly that we don't know that exists. That's the current state of the cloud. An extremely important layer that is extremely opaque. The mission of Akash is to reverse that opacity and create an open, transparent, permissionless layer that all of us have a degree of ownership and a degree of sovereignty that we don't have. That's what Akash's mission is. And we're getting there very quickly. And in certain cases, like machine learning and some of the newer aspects of the cloud usage, it's a lot more visible with Akash than compared to some of the older use cases.
Yeah, I love that. I'm probably going to butcher this, but I remember reading a quote from Jeff Bezos a while ago saying that utility companies to entrepreneurs back then is kind of like the rise of cloud to entrepreneurs today, which I find super interesting and honestly pretty accurate. But what is the elevator pitch for Akash? How would you try and sell someone on, all right, use this decentralized network of cloud computing over an AWS, Azure, etc.?
Obviously, depending on who's listening, right? Because cloud is such an important broad layer, and you had to customize explanation to depending on who you're talking to. For a user, the value proposition is one-stop shop for all your cloud needs. And that seemed to resonate really well. What that means is significantly lower cost than what you would otherwise pay on the cloud to access in some cases when you're talking about machine learning, where getting access to high density chips is just not great when you're just working with a single provider, but rather you want to go to a marketplace where you can get access to a broader set of providers, right? So the elevator pitch is you get access to GPUs that you cannot get access to on Amazon.
So one of the things you mentioned there was a marketplace, and I kind of think of Akash as this marketplace that's matching users and demand of compute with providers that actually have this idle compute. And so when you think about that, can you actually walk us through your unit economics and how and why Akash is actually cheaper to interact with?
Sure. There are two aspects of Akash that's extremely compelling. The first aspect is a super cloud aspect of it. So Akash, um, in it at its core, is a super cloud. A super cloud is, like it said, is a superset of a cloud that aggregates compute across different providers, both private as well as public, and gives you a federated access point. So as a user, to get compute, you don't have to go and integrate with hundreds of providers, but rather come to a single place and you get access to these providers. The second aspect of Akash is a marketplace. So the way you get access to the providers is buying services or leasing services to providers in an open setting, um, typically in a reverse auction mechanism. So you specify your needs and you specify what you're willing to pay, and providers bid on it, and you win the workload. That is an extremely unique aspect of Akash and very compelling because now, um, now you have a degree of concentration of computational power where computational power has been traditionally hyperfragmented. So, what does a unit economic look like? It depends on the resource you're buying. Akash is a general purpose heterogeneous marketplace, meaning you get a wide variety of resources that is not necessarily commoditized because the dimensionality is significantly higher for the type of resources you get than what you would traditionally consider as commodities, being storage or bandwidth, right? So for resources that have less demand, uh, that are usually heavily underutilized, the cost point is somewhere 80 to 70% cheaper. For resources that have high demand, it's actually more expensive on Akash because the free market is going to play out in a way that, well, you're not here for lower cost, but you're here for access. In cases of H100s, which are the most advanced chips made by NVIDIA, optimal for machine learning, currently it takes about 2 years to get those chips directly from NVIDIA, and it's impossible to get them on the cloud. Chips like that, you pay higher, you pay a premium to get access to because Akash is about that open access. Open access is only possible in a free market. A free market economics drive demand supply prices. I mean, the demand supply drives the prices, and that's how it's supposed to work. There are, however, time box incentives that make it extremely attractive to use Akash in the early days. Those incentives are geared towards normalizing prices and offering an attractive price point for developers to be interested. So developers that need access to high density GPUs can leverage these incentives, and again, understanding these incentives are not forever, right? So he has some cost relief there, but pure incentive-less organic demand supply drives the price.
So if we add in the cost, or sorry, the value of the incentives being emitted relative to the cost it costs the actual user who wants to, use this idle GPU power, what does the economics look like there? I guess in another way, how heavily are the AKT incentives lowering the cost from the demand side?
Good question. Currently, there are no incentives. These are incentives that are planned. Right now, it's pure organic demand supply. The planned incentives are being designed with a very important aspect of Akash that's not very common in the rest of the networks is utilization. Akash has near 100% utilization for high density GPUs. Last I checked, it was north of 90% for 1 week timeframes. And about 50% utilization cumulative for all resources, all types of GPUs, including the low-end GPUs. That is a significantly higher utilization than anything you heard of in crypto. For context, Filecoin has 1%, less than 1% utilization of their storage network. So now we have a interesting problem where traditionally crypto has been good at oversupply and less demand. Here we have the opposite problem, high demand and less supply, or the supply that's not yet on the market, right? So we have to carefully design these incentives in a way that we're not over interfering and over price capping these resources through incentives or through protocol enforced price caps. At the same time, we have to ensure there is enough supply in the marketplace for it to be attractive. Like if you go to Walmart, if you see empty racks, not great. Doesn't matter how big the Walmart is. It's really that challenge. So now we're in the phases of doing a pilot because the design space now is a lot more complicated than just pay out for chips that most people were used to, like Helium, right? Like Helium bootstrapped the network massively before getting a demand, and they're still not yet there when it comes to demand. So we're taking a lot of those lessons and designing a mechanism where the incentives are right to bootstrap the network up to 50% oversupply. And once you reach a threshold, the incentives go away, right? So we're trying to optimize for 95% utilization on the provider side with an amortization profile of a year to 18 months for the chips and 50% oversupply for the overall network. So it's attractive for everybody. That's what we are targeting in terms of incentive deployment. This adds significantly less sell pressure or over incentives for Akash because the demand is super high. So we'll know a lot more once we publish our findings and what we think the incentive should be distributed from.
So when we talk about the supply side and the problem of actually generating this supply to then go sell to this demand, where do you think the idle compute will come from? Because I have you mentioned the need for these high density chips like the H100s, and like that's obviously this huge challenge in and of itself. But apart from that, is the rest of the demand going to be potentially from like consumers? Like I have a gaming console under my desk or an old phone. Do those provide like any meaningful value at all, even at some sort of scale?
Right. So it's a good question. If you think about the global distribution of compute power, it's everywhere, right? The best compute power that's hyper underutilized is gaming consoles. Like my PlayStation and Xbox, I use them once a year during Christmas. And most of the time, I'm not using them. And they have very powerful GPUs sitting idle. Two desktops at professional work environments, two data centers, and that goes up the scale, right? The current models, machine learning models, are not yet optimized for heterogeneous machine learning. They are heavily reliant on homogeneous profiles for the chipsets, more so heavily reliant on local clusters for latency purposes. Why? Because the rate of iteration is significantly higher than rate of product building. So what that means is when you're iterating quickly, you optimize to best class in terms of hardware, versus when you're productizing, you optimize for profits and costs that way, right? So the world right now is in a very early stages with AI, and there's a race to AGI. And so as long as there's enough money to fund the chips people are going to be optimizing for speed rather than unit economics for product costs. But as models mature and as models are getting productized, that means products being built on top of the models, not ChatGPT. ChatGPT is a general purpose demonstrator, not really a real product, right? As products get built, now people are optimizing for cost. For example, Copilot is an incredible AI product from GitHub that assists coding significantly better than not using a Copilot. It's one of those products I use very almost on a daily basis. Every time I code, I use a Copilot. I don't code anymore without a Copilot. I pay about $8 per month for GitHub, and it costs about $20 per month per user to produce that. So unit economics is they're taking a loss, $14. That's all not great. Now, how do you optimize it? Well, you can't go after advanced chips, but rather you have to go for something that's a lot less expensive. And the way you do that is by going and distributing your clusters and taking advantage of something like Akash. So that's where we are. We are optimizing iteration over productization because it's very early. So what that means is most of the demand right now is data center grade homogeneous hardware. We're talking about H100s being the most advanced chipsets. H100s is the chip that powers ChatGPT, and I don't know how deep you want to go as to how the cost works, but at a very high level, every time you hit a prompt in ChatGPT, the time it takes to come back, it requires one H100 per each concurrent user for that time. So now do the math. 100 million users, say 100 million users, all of them use at the same time. That's talking about 100 million H100s. That's impossible. They don't exist anymore. So what they have to do is they have to prioritize the H100 time based on how many concurrent users they want to support. And that dictates how fast the application works. More users, less chips means slower. More chips, less users means faster, right? So is ChatGPT's or OpenAI interested in optimizing costs? Yeah, they are, but are they more interested in getting to GPT-5 and AGI? Yes, they're more interested in that. So that's where we are at a level. There's a lot of work happening to leverage heterogeneous compute. There's lots of teams that are working on them, all the way from academia as well as industry. In fact, there's one team building on top of Akash that's too early to say, but one team that's focusing on using heterogeneous chipsets. That means you can train on a 4090 and H100 at the same time, leveraging the compute power from each of these chips. This team is based out of NYU, very advanced machine learning lab. They seem to know what they're doing. There are lots of teams working on it. So long answer short is like, can you home gaming PC use for training? Yes, one day. Not yet. What can I run right now on a gaming PC? There are a few workloads you can run, mostly older models that are optimizing for products versus optimizing to iterate quickly. Older models, be it Llama, even Llama 2 to a certain degree, right? You can run fairly decently on a 4090. 4090 is the most advanced gaming PC, right? The RTX 4090. In fact, the ADA A6000, which is the RTX ADA 6000, which is also considered to be gaming, I assume, but that's getting very popular these days with machine learning. There's more than A100s and H100s because the cost is lower and on-chip memory is higher. So we're seeing gaming PCs actually getting a lot more used, and the rate at which they're getting used is on an uptrend. So that indicates that yes, not very distant future, these gaming pieces will be a lot more usable. But as of now, not really. That's the long-pointed answer as to why where the landscape is.
What's up, everyone? As we explore today's blockchain landscape, let's take a moment to recognize Hexens, the premier cybersecurity provider in Web3. Hexens is trusted by tier 1 projects like Polygon, including a security review of the new Polygon zkEVM, Mantle, RiskZero, Lido, 1inch, Nubank, and more. Get a deep dive into your technology stack with the most comprehensive analysis in cybersecurity consulting. With over $55 billion secured, they cover everything from smart contracts to blockchain to Web2 pen tests.
There has been nearly $7 billion of total value hacked in crypto's nascent history, so it's safe to say that your team has a lot on the line. Don't skip out, take your security seriously, and choose Hexens. Don't forget to mention 0x Research for a free Web2 pen test with your partnership, and you can reach out to Hexens at hexens.io or find them on the ground at DevConnect. Without further ado, let's get back to today's episode. Now, that's super helpful context. Just to kind of zoom out for a second too, because we did touch on how basically you have people who want to buy idle GPUs, put out kind of like a quote and ask for suppliers to fill it. Can you kind of explain maybe prior, I believe there was a change in the Mainnet 6 upgrade to this process. So maybe if you could explain how it worked before and how it works now and any other inclusions in the Mainnet 6 upgrade that are important.
So AKT is the native token for Akash network, and the primary purpose is to secure the Akash network, which is a layer 1 proof of stake network. Without AKT, the blockchain doesn't exist. Right? The consensus wouldn't work. The other options, proof of work, we all know how that goes. So the AKT also is the primary way to exchange value on the network. You pay for hosting using AKT. Providers earn AKT as payment for their services. AKT is also the governance token. We had about 280 or plus proposals so far, all being managed by AKT. Right, so it's a very active governance. AKT is also a sustainable mechanism for development. There are about 250 developers or contributors on Akash network. Some incentivized, some not, but they're actually AKT incentives if you actually develop on Akash network, and that comes from a public goods funding mechanism on Akash, right? So AKT is integral to Akash. Without AKT, there is no Akash network. But if you are doing long-running workloads, that means if your application runs over a day or two, or maybe a month or week, right? The volatility of Akash AKT token is not great for user experience, because depending on the price, either the provider or the payer is impacted. So there has been quite a lot of requests for stable payments, enabling essentially something like a USDC. And the challenge with enabling USDC is, well, it undermines AKT utility, which undermines security of the network. So the AKT utility or the security of the AKT token or Akash network in general is directly proportional to the economic value of AKT, because if the economic value of AKT is lower than the economic activity that happens on Akash network, it becomes a target for adversaries. So that's why if you use USDC, you pay a fee to the blockchain, an incentive that's distributed eventually to the AKT holders in form of a take model. So you are either taking or making liquidity on the Akash network, and using USDC, a portion of the fee goes back to AKT stakers as an incentive to secure the network. That's the role of USDC and AKT right now.
Okay, great. Yeah, that's super helpful. And I was curious, so what's the idea behind keeping fees so low? Like 80%, yes, that's probably enough to like be like, all right, I want to use Akash opposed to an AWS potentially. But given how important this value accrual is for AKT and the security of the network, have you guys ever thought about maybe increasing that, or I guess just what's your plan on that long term?
So we don't have any control over price, right? It is a free market that sets the price. So the price is significantly lower for resources that have low demand. So the prices you're seeing on the dashboard are probably resources that are commoditized heavily, Right. But price is not lower for high density chips. For A100s, for example, is actually much higher, or H100s, than what you would normally pay on the cloud. If you can pay on the cloud, that is, right? So I don't think you have too much options. But we let the free market set the price. We, as Overclock Labs, the core team, we may provide guidance as to how you want to think about the price, but we don't dictate what the price should be, and we'll never will. And that's critical to the protocol to function. And so if somebody is just having a bunch of A100s, they're not training, they just want to put them on Akash, they are, I don't know, they got them for lower cost, and they just want to make some money, right? Like, it's great. In fact, it's very interesting when you talk about price. It's funny enough, you think like, oh, if there's a resource that's like has high demand, maybe people should just charge high. That's not entirely accurate, because a lot of times, in fact, you can write off your depreciation of your chip as a loss in your taxes. Is a lot better. It is sometimes beneficial to charge lower for even high demand chips and write off the loss and the amortization in your taxes than to actually make profit of running this leasing operation on Akash, especially if you have a profitable business unit that's making too much money. So you think about these interesting patterns where we have a, a machine learning company that bought A100s a long time ago, and now they upgraded to H100s, and they have a fleet of A100s that are not being used. And now the question is, do you sell that chips in an open market, or do you lease them on Akash? It's actually beneficial to lease them on Akash, because you can write 25% amortization of the value of the sorry, you can not amortization. You can write 25% depreciation every year against the value of those chips as your tax write-off. Than any money you make on the chips that's actually considered to be profit. So it's like, so there's a lot of advantages to actually lease the chips out than to actually sell them in open market.
Okay, got it. That makes a lot of sense. I appreciate that color. And yeah, that, as you said, the supply side, or sorry, the demand side is actually setting the price here. So it's really not in Akash's control. It's really like the free market deciding it, which is probably the healthiest way to price these resources anyways. But on the demand side of things, who do you see as your biggest customer? Because, you'd think Jim Bob building an application, maybe would want an AWS because they know it's going to work, super reliable, not experimental. And then maybe for you guys, it might be a VPN provider or maybe node operators. I'm just kind of curious where you've seen the most demand come in.
So right now, most demand comes from machine learning developers looking for on-demand A100s or H100s or A6000s. Why? Because there is no place right now on the cloud you can get on-demand access to A100s. Amazon, Google, Microsoft do not have A100s or H100s. And Akash has, because Akash is a marketplace that's sourcing these chips from places that normally have no way to get them directly from. So it's a very interesting. Almost all our A100s are gone, right? So we're ourselves struggling to get more A100s, and there are several things we're doing. So from a interesting usage patterns we're seeing recently, we saw a full foundational model proposal to run on Akash that consumes about 24,000 A100s. This is the first time ever a foundational model is being trained on a decentralized cloud. The notion today that, hey, foundational training is a lot better on centralized versus decentralized is going to be debunked, right? So we're, like I said before earlier in the podcast, we need to understand and we need to learn how to deploy these models on a decentralized network versus a centralized network, because so far it's always centralized because that was the only option. For the first time, we actually have a viable decentralized option. And also Akash released GPUs a month ago, so it's very, very early. And as people play around with these GPUs, they're realizing, hey, you can actually do a lot more, right? So the 24,000 A100 hours is a large scale model deployment. So we're super excited to start that. A lot of other users are typically people that that just want access to A100s and want to scale with the users. So we're seeing a lot of inference use cases. Like I said, inference is one of those things that scales with the users, right? So every additional concurrent user you have for your application needs an extra chip. So training is like a one-time job, but inference is more of a continuous jobs, right? So we're seeing quite a lot of demand from inference, and I think that's going to be a trend. I think 80% of our demand is going to be inference, and 20% will be fine-tuning and training. Third type of application that we're seeing is fine-tuning applications. Fine-tuning applications are essentially models that learn from the user and continuously improve based on users' data set than just inference models that don't really learn from you. Like ChatGPT doesn't learn from you. ChatGPT does things for you, right? It doesn't, uh, uh, not yet, right? It doesn't yet um, customize how it speaks based on how you speak. For example, like you can't train ChatGPT to be like speak like the way I speak. Learn from all my emails, right? Like, and write an email like the way I would write an email, right? Make the imperfections that I normally have in my communications because ChatGPT sounds too proper and too right. I don't want that to sound more human. So things of that nature, you need to fine tune the system. So that's not quite possible today on shared models. So folks want to do their own fine tuning. A big challenge we see with Copilot is Copilot is great for recommending code, but it doesn't learn anything from my code. So it'll give me random examples from the globe, and I don't consider there are more bad programmers than good programmers. So you end up getting code that's lower quality than higher quality. In order for it to be higher quality or the quality I deem to be higher, I wanted to learn from me and my team and code repositories that I deem to be high quality. So that we call that fine tuning, right? So there's quite a lot of use cases of fine tuning that's coming onto Akash, and also privacy use cases where, hey, I want you to train on my code. I don't want to share my code to the rest of the world for them to learn and out innovate me. So a lot of sovereign AI, we call it, use cases that are coming on Akash. There's a lot of incredible use cases that are not that people don't want to use the cloud for.
Okay, that makes a ton of sense. And one of the things you mentioned was the recent proposal that passed. So that proposal was for 24,000 A100 hours. How hard is that going to be to like actually obtain those hours? Like, does the network have those chips available today?
Ramping up, not yet. I mean,
Okay.
all the A100s are gone, so we're working with providers to very hard to start this model. We do have access in the pipeline to get these chips. The question is how and when, because the chips are in high demand. Um, yeah, it's definitely possible. We ran a bunch of benchmarks. We have a high degree of confidence it's possible, but only we're going to know is like actually do the training. So God knows what we're going to find on the way, but we're very diagnostic, optimizing for hyper diagnostics than like, hey, correctness and whatnot. So we're lots of, it's still an experiment, just put it that way. It's very like experiment that pokes everywhere and understand like what the message passing latency and how do you balance that out with your compute costs. And there's a lot of, we'll publish a very incredible, highly in-depth report as to what the trade-offs are trading on a decentralized network and what the cost profile looks like, right? So far, our confidence level is fairly high that this is going to be easy to pull. I mean, it's going to work, and we should see a functioning model in 3 months if we play our card right. But
Okay, nice. And that was going to be my follow up is like, obviously we got to get out there and test in production to really figure out the actual specifications. And I'm super excited to read that report that your team will put out. But like, what are your early suspicions about what the benefits will be? Like, is it going to be cost? Is it going to be speed? Is it going to be like, what are going to be the real drivers of why decentralized cloud computing is better than centralized specifically for training these models?
the most obvious benefit is going to be price point, price performance. how much are you paying for what performance, for how much performance you're getting. The goal of Akash is to reduce that price for the performance that you're getting. Right? So, of course, this particular model is homogeneous in the sense it requires A100s and A100s only. The next big experiment will be heterogeneous training, right? Can you use 4090s? Can you use A6000s or H100s or whatever we can get? So this is not the end of our experimentation. The benefits are obvious, cost. Can we actually use a decentralized network for training? No one has proven that so far, right? So if we can prove we can use a decentralized network for training, then we may not get the cost advantage on the first run, but we can put a model where if the cost of A100s is lower, especially the subsidies that we can offer in the early days at least, it might be actually beneficial to run a decentralized cloud. So yes, the goal is to prove that price point is an optimal price point to run a decentralized cloud than a centralized cloud. On top of the fact that, hey, GPUs are the new oil, and whoever has GPUs, essentially controls their destiny in terms of their AI, right? I'm a big believer in sovereignty when it comes to AI. I'm a big believer in decentralized compute networks where I should own the A100s or H100s, that trains my AI, and I want to control the cost. Like today we saw the invisible tax we all pay. Half of every dollar we pay goes to a tax collector that we don't know who. I don't want that to be for AI. For the first time, we have a new technology stack that's emerging post Web3, which is AI. So the question is, how do we want this to be to evolve? Right now, we have a decentralized network as a viable option that we did not have with the previous generation of technology. So yes, it's very important that this experiment succeeds because it not only shows us that it's possible, but it's also possible the price performance that we like as a society.
All right, everyone. I'm excited to tell you a little bit more about crypto's flagship institutional conference, the 2024 Digital Asset Summit in London. The UK's open regulatory environment has laid the groundwork for growing institutional adoption. DAS brings together over 600 institutions that manage a collective $800 billion in assets. So there's no better place to hear perspectives on digital assets than straight from the world's largest capital allocators. This year's speakers lineup is fantastic, and we're going to hear insights on macro trends, RWA adoption and utility, the fluid regulatory landscape, the evolution of stablecoins, and more. Between the all-star speakers and the relevant topics, DAS 2024 is a can't-miss event for anybody interested in the growth and maturation of our industry. Hit the link in the show notes to secure your tickets and be sure to use the promo code 0x20 for 20% off. I look forward to seeing you all at DAS London in 2024.
So you all made the decision to move on from Ethereum, I believe, after experiencing some performance issues, high fees, etc. Not sure the exact reason, so maybe you could shed light on that. But then I heard you mention earlier in the conversation, we have to be mindful of the economic value of AKT because it's inherently tied to the security of the network. How would you, I guess, define the trade-offs between the two tech stacks? And if you're doing it over again, would you make the same decision?
We began prototyping on Ethereum in 2016. So very early, before we wrote the white paper, we wanted to do a proof of concept and check the viability of a decentralized stack, whether it's ideal for a infrastructure network like Akash, right? And we actually have built a prototype in 2017, 2018 timeframe, and we deployed that. And around the same time, CryptoKitties launched, if you remember that. So that brought in 40,000 new users to Ethereum network, which crashed Akash for like a few days. We couldn't use Akash. Ethereum network was not in any form or shape ready for even decent usage. Not even scale. We're talking about 40,000 users, right? So then we started foraying into building our own layer one because as much as experience I have building distributed systems over the years, I prefer paying for a service versus building a service any day. Especially in early days, I prefer using a shared service versus a dedicated service always, right? We go with a cloud first before building our own data center. We go with a cloud database before hosting our own databases, right? And when you begin. So I am very big supporter of using a shared service than a sovereign service in the early days and scale as you get to sovereignty, right? I think that's the right way to do it. Unfortunately, in 2018, 2017, there was no option for us to do shared service that's viable. Now you have layer twos and other options, but back then it was impossible. And I actually was working with Solana in 2018 before they launched. I mean, good friends with Anatoly, and then, in fact, I don't know how many of them know we are Solana's first partner. First announcement, I think, is Akash and Solana. We were exploring deeply because I really care about if I can offset the security budget that we have to incur using a app chain. I will do that, especially in early days where you have to reserve your incentives for behavior rather than security, right? Because it's very hard to justify the security budget that we have, that we're incurring right now, to the economic value that's happening on the chain, right? That's the challenge with app chains is like in the early days, no network will have significant economic value unless you're doing something financial. It's a different use case, but for any normal software like Akash, which is just a marketplace, right? You will not most likely not have the amount of economic activity to justify an economic budget that you incur with app chains. So if I were to do it again, I would always use a shared service like Solana's of the world or the layer twos of the world today. I think Solana has something that other layer twos don't offer, the fast finality, if that's what you're looking for in terms of your application design, right? So there are lots of options today. I would highly recommend using a shared service versus an app chain. While the pattern should be using a shared service, hitting the limits of scale, and then moving to an app chain, now we have a justification you can do for your security budgets. We're also experimenting actually using a shared model with Bitcoin. If we can offload some of the older transactions to Bitcoin and use Bitcoin as an archival chain, we can reserve the Tendermint side, the layer one side of Akash for fast finality transactions. That way we can optimize the security much better. So we rather pay a Bitcoin's network because Bitcoin is arguably the most secure chain. There's no doubt about it. And use Akash just for the fast transaction, just like how you would use like a caching layer versus a big database, right? So you don't normally always write to a database if you're scaling systems. You need something in the middle that gives you the performance you need, and then eventually do an asynchronous write to the database. So the design space is wide open right now in terms of like app chain versus modular versus shared state chains. And I think all of us are just learning. 5 years from now is going to be very different, right?
Why build all of this on a blockchain in the first place? Because the problems you just described are like, in some ways immovable mountains, and your team has to spend time thinking about building the best product, this marketplace, as well as building the infrastructure that actually supports this best product. And so, what benefits of the blockchain of a blockchain in general are like, okay, this is worth the extra effort our team has to go exert and to make this thing possible.
It's a big topic, but the most important aspect for me, and everybody has their own views as to why blockchain, for me, is open source enablement. There is no model today that enables complete open source software to be sustainable, to be actually functioning, right? Like if you look at the business models for open source software, is the most viable one is open core. Open core means you open source a part of your software, but you keep the majority closed, and you charge money for it. That is inherently against all the ethos and values as open source developers. Like Linux was never open core, right? Any software that's sufficiently scalable and TCP/IP is never open core, right? Imagine TCP/IP being open core. Imagine saying that, hey, You can send basic packets, but the moment you want high speed, you pay to TCP/IP's company that has shareholders. So if you want to create really hyper scalable, that has network effects, that's purely open source, decentralization is the only way I can challenge anybody to challenge my assumption, because there's none. Now, okay, why? Because crypto adds a network aspect to open source that never existed before. Akash is possible because it's open source, and open source is foundation for hardware, for anything infrastructure, right? In 2023, if you're a closed source company and offering infrastructure products, people will laugh at you. I mean, people will not take you seriously to any degree. So forget getting any degree of adoption, let alone the other benefits open source software comes with. Contributors, Akash has 250 contributors, right? Most of them are contributing to Akash network because they love the network and because it's open source. Akash, we saw recently that Akash is being experimented with in Department of Defense because DoD sees some value in open source software, and they're able to audit the software. They're able to look at everything underneath the hood. So when you have to deploy something, infrastructure in something like a military establishment, good luck trying to do that closed source. Right? So open source goes to places where closed source cannot. Open source can go farther where closed source can go faster, but not as far as open source can. Right? So if you want a truly global scale, globally scalable, globally reachable network, it has to be open source. AOL, even though it provided value, did not succeed compared to an open source web browser. Right? And there's a reason for it. Right? Windows doesn't have nearly the kind of distribution that Linux has. 98% of the web runs on Linux. Why? Because open source, right? So open source is very, very important for globally acceptable technologies or technologies that spread across the world. Now, how do you make open source sustainable? Crypto.
I love your framework for all of this. This has probably been my favorite question thus far. And so, you've mentioned the security budget and how your thoughts around that, and you mentioned using the AKT token for incentives, and that kind of just is like real time proof that using a blockchain gives you this liquid token that can be used to kind of drive these extra incentives or really just like increase the participation in your product. Are you guys trying to think of any other maybe like novel approaches to how a token can be used in a way that like a Web 2 company can't really compete with?
Well, you have incentives, right? I mean, like, for example, the shared ownership of the network is very powerful. Like, I built software. I mean, 15 years I've been focused on developer software. Before Akash, I founded AngelHack. AngelHack is the largest hackathon-based accelerator in the world. 150,000 developers. We had every developer company, every Web2 developer company sponsor our events, GitHubs to Twilios, and I had firsthand experience working with a lot of very successful developer companies and working with developers that build on them. Right, a common thread happens to be if you are a company building on someone else's API, right, to advance your interest, the moment your application gets popular, your API gets cut off. We saw that happen to, God knows, like so many companies. There has never been a hyper successful company wherein that's built using someone else's APIs, except for maybe Stripe, because Stripe is the only company that gives you payments with API. But for the most part, you cannot build, especially on Amazon, right? Like the moment you get scale, Amazon will outcompete you, or will try to acquire you. How do you build something that, as a builder, you have guarantees no one's going to pull your plug on you the moment you get success? Because that's a precondition for me to build something on someone else's tech. Akash, no one can pull plug on you if you're building on Akash. So we have 8 different companies now building on top of Akash, different clients, different protocol clients, customized for their businesses and customized for their users. And they have guarantees that you're not going to pull the plug, and they have guarantees they can get GPUs on Akash. Right? Today, it's impossible to get GPUs on Amazon unless you're Anthropic, where Amazon will invest in you. Unless you're this company, unless it's profitable for Amazon. So Amazon will choose who gets access to the APIs or who gets access to resources. Akash, you cannot. And that's the beauty of sovereign permissionless systems, right? So that is such a powerful guarantee that Web2 can never provide, ever, right? So, and second is network effects through token distribution. The reason, so Overclock doesn't have salespeople. I mean, we have BD, but we don't have salespeople. Especially, we don't have salespeople that's going to DC and doing lobbying to use Akash for DoD. But guess what? We have token holders that work for the military. I mean, DoD. There's a group of folks in DoD that, in Space Force, Air Force, and Marine Corps that we know of, that love Akash because of values that are aligned with the sovereignty of military. I consider to be the purest form of government, and that actually are incentivized because they own a part of Akash. Now they have incentives to go take Akash to places where Overclock Labs cannot ever. Try that, doing that with a Web2 company, right? And now we have on-chain incentives. You actually can get paid. There's a proposal out there that'll enable these incentives to, as a provider, by providing compute to Akash, you earn a portion, or you get to own a portion of the network itself, which then lets you participate in the governance in terms of how much take rate you need to take. Well, if you have a problem right now, there's 20% take rate that's governed by Akash AKT stakers that is voted on chain. If you want to reduce the take rate, well, make a proposal and gather votes and gather support. So you control the destiny of how much you want and how much extract to the protocol is in protocol. There's not a single Web2 company that can control that. You as a user control. So try doing that with Web3. So there's enormous benefits open, permissionless, self-sovereign systems bring that Web2 can never even scratch the surface of. So those are just 3 use cases on top of my head what Web3 can do that Web2 cannot. Like impossible, not even like.
That's fantastic too. I agree wholeheartedly with everything you said. So we've touched on a lot of things here, but one thing I feel like we haven't touched on just before we go, I do want to get your take on kind of the supply side as it looks today. So, what percentage of these idle GPUs are like completely independent, just organic growth that hasn't been maybe someone affiliated with the Akash Network core contributing team? And then I'm also curious if there isn't 100% uptime or the performance is poor, what are the ramifications to the party supplying that power?
So Overclock Labs operates one provider. We have about 50 providers now on the network, I believe. One provider is operated by Overclock Labs. That's 100% utilized right now because we are. I don't even remember the name of the provider because it's a test provider, right? We don't have enough supply to satisfy the scaling needs of people. Our biggest contributor right now for Akash is Foundry Digital, which is owned by DCG. They, I think, bought like 56 GPUs or something. A lot of the A100s come from them. We had no idea they were going to be on Akash. They just showed up on day one. So then I had to scramble to get to know them, and I had to go hunt Twitter handles and get a relationship that way. But our relationship established post usage, not pre usage. It's very important to recognize there. So all of our providers, to a degree, are operated by independent companies, right? And it's definitely very challenging not having control. And I mean, you're used to it, but the channels you have is just public channels. You don't necessarily have, they're not on your payroll, so you can't call them up in the middle of the night if something goes wrong, be like, fix it, right? Like, so you have to learn how to operate in a decentralized environment as a company that's trying to push the product out, right? It's definitely challenging. So the ramifications for underperformance is there are 2 aspects of Akash, right? Akash has a reputation model. It's not a trust or like trust-free model. There's always a degree of trust, right? Because you need to understand what the providers are. To improve reputation, we have something called decentralized network of auditors, attribute auditors, they call them. So every time a provider advertises a set of attributes, be it identity, be it performance, be it chips, or be it whatever attribute they say they have, it's audited by a decentralized network of auditors that do off-chain auditing and publish a proof on chain. So you, as a tenant that wants to use a provider like Foundry, can choose an auditor and establish a trust by association instead of having to trust them directly. All aspects of performance is published on chain, so uptime is the most important aspect. And Akash doesn't. Akash has a bidding engine, doesn't have a matching engine. That's by design, because ultimate decision on what provider you choose depends on you. So you end up choosing what provider you want. So Akash doesn't make the choice for you. So you have complete control as a tenant on where you're deploying and who you're deploying to and what price you're willing to pay. So that way we can fight for fraud, right? So of course, if you have a fraudulent provider, you're never going to use them. It's just like how you would not use a fraudulent seller on eBay, right? And as more number of people use a provider, the confidence level for you to use a provider goes up, because this provider has been around for a long time, actually serving workloads and actually audited and signed by auditors and whatnot. In fact, one of the auditors, one of the most popular auditors in Akash, is called Moultrie. They're DoD folks. They're former DoD. So they're the ones who implemented Akash internally and got successful, and they actually left their jobs to start a company that to run on Akash. So there's quite a lot of like incredible stuff that happens in the network. And of course, if you want your networks to be audited by DoD folks, right? And these are security specialists working for DoD, so they seem to know what they're doing. The ramification is just reputation, and you have lower reputation, you get lower business.
Right on. I think that makes a ton of sense, and I love the anecdotal stories you can include about the type of people that are working and involved with Akash as well. That kind of just came out of their own passion and desire to see this network succeed. But Greg, this was an awesome conversation. I really appreciate you joining us today, and I'll just kind of give you the opportunity to leave the audience with like one final thought, or where to learn more about Akash or hear from you, because I know you're a great follow on Twitter.
Oh boy, final thoughts are always hard. So final thought is, I guess in light of what's happening right now with SBF and seeing the whole previous generation of bull market celebrities are getting washed out, and you have entering a new cycle, as we like to call it. And I want folks to understand that it's very important for us as an industry to self-regulate bad actors versus the government having to do that, which most likely is happening today, right? We want, as an industry, a self-regulated pattern, and it's very important to recognize a project's foundational, whether it's closed source and open source. There is an enormous amounts of projects in the top 100 CoinMarketCap listings that are closed source projects. And it's very, very important to recognize them and weed them out, not giving enough input. I don't want to name individual projects, but please keep, whenever you evaluate a project, make sure that you can actually go to the GitHub and see the source code and actually see the people working on the project versus blindly trusting because they have a bunch of partnerships. I think it's very important to reverse that. It's very important to look for signals in the noise, and the signals are usually are hidden in actual work, tangible work. And it's not that hard if you look at someone's GitHub versus someone's Twitter handles or whatnot, right? So don't trust Twitter as much as you should trust GitHub. But also check me out on Twitter, Greg Osuri, because most of my tweets are about going back to my GitHub. So that's the final thought I want to leave out with. Just be very careful, and we owe to ourselves this time around to self-regulate as an industry, so we can avoid the pitfalls that we fell into last time, where you have closed networks, like every, for the most part, I would say, to a certain degree, every failure can be attributed to closed and opaque models. I think about it, like FTX, Celsius, even Luna, to a certain degree, to a large degree, it was very close, right? And people didn't care or people didn't seem to care the fact that all these are closed source networks that are leveraging open source or open networks to create false sense of success, and that led us to trouble. So let's do a better job this time. Let's make better mistakes tomorrow, I call it.
Wise words, Greg. Wise words indeed. We'll be sure to include your Twitter link in the show notes, as well as we'll go ahead and put the Akash GitHub link in there as well, so people can check it out. But again, thank you so much. This was a great conversation. Appreciate you coming on and spending some time with us. Cheers.
Great time, guys. Thank you so much.